my projects use a lot of lime plasters, for example, and lime plaster was used. If you have a period property and you take the wallpaper off and you get to the plaster, and if it hasn't been touched, it will be an original lime plaster, and it'll be about 20 to 25 millimeters thick. It'll be nice and thick. So we're and if it's in good condition, we can reuse it. If it's not, and it's had lots of repairs, and there's cement plasters or gypsum plasters all mixed in, then we have to take it off and go back to putting a lime plaster back on as our substrate before we put insulation on there. So I think maybe the surprise is how much effect we can have in terms of reducing the carbon impact by using the materials that we're using, but also the carbon impact of the heating, because 28% of carbon emissions worldwide are to do with powering our buildings, and being able to reduce that massively in a project, I guess there's an element of surprise and excitement over that. We've got a project where we reduced it by 90%. And that's like a really massive, it's really huge.
So is it like a passive house style, or was that, and you've mentioned lime plaster, is that connected to lime plaster as well?
So we've used lime plaster because it's often the part of a system where you've got, for example, wood fibre or cork, and they end up with a lime plaster as the final finish. I can pick this up.
So this is lime plaster example here that you're holding up.
Yeah. So basically, we got a cork base, and it could be a wood fibre one as well, which is there.
Yeah. And
that might go straight on an external wall internally or externally. And then it then has a build-up of like 3 layers of plaster. So you get a base layer, which usually has a little groove in, and it can be as thick as 5 millimeters thick. And then there's like a mesh that gets pushed into that. And then there's another layer that smooths that out. And that's another 3 or 4 millimeters. And we try and get that smooth. And then if the client wants a really, like a really fine finish, like a gypsum plaster finish, then there's a fine finish that goes on that if it's internal. Or if they don't mind it a little bit more rustic, we can keep that first layer, that smooth layer. So that goes on top of the insulation. And one of the nice things about it is it gives a 1 hour fire protection with it being 10 mil thick. So that's quite nice. The other thing that's nice about using these materials, they people do ask me about fire. That I've just touched on it, and they're not, they're natural materials. They will burn, but they have a tendency to smoulder and not leap into flame. And then the lime plaster on top is protecting them for an hour anyway. And we put in plenty of fire alarms. It's good practice to put plenty of wired-in fire alarms. And it's something that people talk about since Grenfell. We're all much more aware of fire.
So just coming back to these materials here and this thing, can I just grab it?
Yeah, sure.
I'm just grabbing this thing. So, so the cork element, you're saying that will go on the inner skin. So you'll have your outer blockwork.
Or brick wall.
Then you'd have a cavity.
No
cavity.
No. Let's think of it in terms of a period property.
Okay.
So you've got a solid brick wall and 225 mil thick or 330 mil thick, depending on whether it's 2 or 3 bricks, the width of the wall. So it's solid brick. And then the existing wall would have a sort of 20 mil of lime plaster internally if it hasn't been touched since it was built. So if we're insulating internally, we take off. If we have to take off that internal lime plaster, we take it off. Then we put a sort of smoothing lime plaster back on to get the wall smooth and level. Then we put an insulation board. It can be either there's a number of materials that you can use, but we have a tendency to use either cork or wood fibre so far.
So this cork here would be used as insulation.
Yes.
And so what would be the insulation properties of this cork when compared to something like a rock wall or a...
In terms of lambda values, they're not that different.
Right.
So the performance is not that different, and it's the same with wood fibre. So we tend to use the cork in more wet areas. So like a bathroom, for example, it's slightly more pricey than wood fibre, and then we'll use wood fibre in sort of bedrooms and living spaces and things. But cork would be where there's a bit more moisture. In terms of, it's good to think of it in terms of optimum performance. It's one way that's good to think of it. And when you're reducing the U value of we want to get the U value down. And a typical sort of, people refer to them as 9-inch brick wall, but I don't really work in inches, but 225 millimetre wall is typically, the U value is about 2. And if you put 40 or 50 mil of wood fibre, of a wood fibre board or a cork board, you can get down to 0.47 or 0.5. So that's sort of 75% better. And then if you add it, if you make it thicker, so you make it 80 mil or 100 mil, you're only actually ever taking it up by another 10% or so. So the optimum is around 40 or 50 mil,
Fine.
which doesn't take up too much space in the room, and it costs less.
And so how does that compare then? So when I'm looking at these two insulating materials, just hold this other one up as well, just so that the viewers can see. So this is a wood
Fibre.
Yep. Wood fibre insulation. So how would this compare to a PIR board in terms of the insulation level?
So a PIR board has the lambda value is lower. So a PIR board is supposedly more, will reduce the energy loss more, the heat loss more. I say supposedly because there's all sorts of things with PIR that don't work so well with an existing building. So, for example, these materials are vapor open or breathable, as some people like to say, but it's very confusing. Breathable sounds like it's allowing air through. It's not allowing air through, it's allowing moisture through. And moisture molecules are smaller than air molecules, which is helpful because we want the moisture molecules to pass through and we want the air molecules to stay in so that it's airtight. So so PIR is not allowing moisture to pass through. So that causes a potential problem. The potential problem is that the bricks in the winter get wet from the outside and then they dry out in the summer, and they're drying out in both directions. They're drying out into the property and out and outwards. And you put something that's blocking that moisture passing through, you're stopping that drying out process happening so easily.
Thanks for watching to the end. I think that you'll like this, but before you do that, just make sure that you've commented and liked below, and also that you subscribed.